Got my coffee early in the morning. I'm a terrible singer. I have a terrible voice. I definitely don't have a radio voice. I don't have a radio face or a TV face. I'm just me, but I do have a love for coffee. Chapter number 10 is what I like to call the bro chapter or the meathead chapter. And I can say that because I am a meathead. At least I self-identify as a meathead. A little bit I want to get into. I kind of go into a little bit of a rant during the PowerPoint within the first slide. I kind of want to talk a little bit more about it afterward here in the outro, but we'll get into it. I don't want to go too far into depth here with the intro, but this is definitely a fun chapter to talk about. So we go into some aspects of some adaptations that occur with resistance training, hypertrophy, some of the strength gains, maybe endurance gains, but also looking at maybe hyperplasia potentially, and maybe any type of change within the muscle fibers. So in terms of going back and forth between 1 and 2, type 1 and type 2 muscle fibers. And then also delayed onset muscle soreness then to kind of wrap up the chapter. So without any further ado, here's chapter number 10. Enjoy. All right, chapter number 10, adaptations to resistance training. Let's get on with this fun chapter. All right, I have a bunch of different descriptions of people on the first slide here. And I want to go into some things about some myths, misconceptions. Resistance training can be used to increase strength, power, and muscular endurance, and it's beneficial for everybody. It's just not meatheads in the gym, all right? It is for everybody. Men, absolutely. It's beneficial for men to increase strength, power, muscular endurance. Athletes, non-athletes. Athletes obviously have a benefit of increasing performance, but non-athletes, it's very beneficial. And especially once we get into maybe older age, which I'll get into here in a second. But with the athletes too, there's female athletes and there's male athletes. Well, the females are going to benefit just as much as the men do. Now, women can't gain as much muscle mass, but pound for pound, they're going to get just as strong, if not a little bit stronger pound for pound, based upon some of the data that we have. And this is where some of the misconception comes in. It used to be said, "Oh, women can't weight train." They're going to get too bulky and they're going to get too big. Absolute 100% pure bullshit. Females, most of them, cannot get nearly as big as men, all things being equal. And I'm not talking about taking steroids or whatever else. Females can benefit just as much, if not more, and gain more strength, possibly pound for pound, as men do. They might not gain as much absolute muscle mass and absolute strength or power, but they still will gain it. It's still beneficial for health. So we're going to end that now. That is certainly something that is long past. We already know that, but way back in the day, and in fact, there could be some old fuddy-duddies that are still saying it. But the reason I bring it up is because there are still coaches. I'm talking about collegiate coaches that are saying that they don't want their females training because they're going to get too bulky. What is going on? Somebody needs to slap these people upside the head. There's no way it's going to happen. Unless they're taking steroids, ain't going to happen. All right. So end of story there. Let's switch to younger individuals. It used to be said you should not weight train before hitting puberty. In fact, there's some people that say you shouldn't play sports before puberty. But let's just stick with weight training. The myth was that somebody was going to weight train and they were going to stunt their growth. In fact, I hear some people that are a little bit older than me. I'm in my late 30s right now. People in their late 30s, early 40s. Oh, I stunted my growth because I did a lot of weight training when I was younger. It's like, no, you didn't. You're short because your parents were short. End of story. Like that, genetics is the only reason that you're short. Okay. I mean, unless you had some type of massive injury that broke the growth plates, but I can guarantee you it wasn't from strength training. In fact, any type of training for younger individuals is actually going to help them grow more. Again, as long as they do it with proper form, proper supervision. We do know that weight training is still beneficial, even for prepubescent children, and that's boys and girls. So it can be beneficial for the young, for old people as well. This was probably one of the biggest misconceptions for a long period of time, in that older people, we're talking about people in their 40s, 50s, 60s, and even getting into their 70s and 80s, should not weight train. Oh, Grandpa, you're going to break a hip. No. In fact, the weight training can help prevent that. It can help prevent it by increasing the bone health, the bone density. You need resistance training for that. So we do know that now, that it's beneficial for older individuals. In fact, it's probably even more important than any type of cardiovascular training, just because the daily activities concept. If somebody is getting older, the weight training is going to help for them to be able to lift the groceries, to be able to go up and down the stairs, lift the grandkids, play with the grandkids, stuff like that. They don't need to be power cleaning. They don't need to be squatting, but doing some TheraBand curls, doing some, if they can do push-ups, that'd be beneficial. They can do some type of sitting exercises where they don't need to be standing very much. They could be using soup cans to do curls. There's a whole myriad of exercises that they can do that is going to be beneficial to them as they get older. So to sum this up on my little rant here, resistance training is beneficial for everybody. It is safe for everybody to do as long as you know the proper form and taking the proper precautions. It is safe for everybody. You're not going to stunt your growth. You're not going to get too big. You're not going to break a hip. Everyone is going to benefit from it. Again, as long as you do it properly. Okay, let's get into some neurological adaptations, the meat of this chapter. So the motor unit recruitment becomes a little bit more organized, and they act in unison, or more synchronous, if you will. They act in a certain order for maximal force production. And as somebody starts weight training and continues that weight training, it's going to get more and more unison. The body's going to start to figure out, and the brain and the body both are going to start figuring out, okay, this is the pattern that we need to fire this at to maximize force production. The other adaptation that could occur is that there's an inhibitory stimuli that decreases the Golgi tendon organs. So what this does is it helps to reduce the inhibition of the GTO. Remember, the Golgi tendon organs will start to increase the force production in the antagonist muscle if we put too much strain on the agonist muscle. So that decreases that inhibition. So we're inhibiting the inhibitor in that case, and this helps to increase the force or the strain on the muscle, which then can lead to more beneficial strength improvement. Now, this is all known as neuromuscular adaptation. This is part of that neuromuscular adaptation. And this usually occurs within 6 to 10, maybe 12 weeks of the initial weight training start. There's two different types of hypertrophy that we'll see. We see transient hypertrophy, and that's really those couple of days after beginning a weight training program. There's going to be a little bit of swelling. If you've ever gone through this, you know what I'm talking about. The muscles are a little tender and they almost feel a little swelled up. That's because there's some fluid buildup. There's some edema, and that's from the plasma. So that's not true hypertrophy, even though the muscles are still enlarged. It's not permanent. The more permanent, or at least semi-permanent one, depending upon how much training you do afterward and also any type of detraining that may happen. But the one that's more long-term, this is going to be the chronic hypertrophy. So this is the actual increase in muscle size. And this is maximized through eccentric phase. So there's an increase in hypertrophy and strength gains during the eccentric phase because there's more damage during that eccentric phase. This is where a lot of the protein modeling will happen afterward, after those exercises. The body's response is to, okay, I need to get in there. I need to clear out any debris, any of the small little proteins and molecules and that are there. Need to get rid of some of the swelling, but I also need to bring in some more protein and structural components to build that muscle tissue back up. Now, most of the time this occurs because you're increasing the size of each individual muscle fiber, and that's true hypertrophy. Does hyperplasia occur in humans? I've mentioned it before. Yes, it does. Do we know how much it occurs? How often? No. We're just not sure exactly how much hyperplasia plays a role in increasing the overall size of the muscles. But we do know the increase in size of each individual muscle fiber, that's the major component. Looking specifically at fiber hypertrophy, there's an increased protein synthesis during recovery. So the protein is being broken down during the actual exercise itself. Getting into a little bit of what's going on here and maybe some ways to maximize the increase in the size. One, there's a massive amount of testosterone that's released and also growth hormone. And we'll see in chapter number 16, we get into some of the supplements, either legal or illegal. Getting testosterone and growth hormone, that's beneficial. We do release it naturally, however, but another way that we can help to maximize this, in addition to the testosterone and growth hormone that's released in our bodies, is by adding a little bit of protein and also carbohydrates for recovery. And the carbohydrates are used to replenish some of the carbohydrates that were lost from the glycogen, but also it helps to get some of the amino acids into the cell. And that helps to get the amino acids into the cell and helps to get them in to do what they need to do to build the protein. Now, there's two pictures here down on the bottom of the slide. One of them is just showing what the muscle fibers were before training and then after training on the right side. So just showing the increase in the size of the fibers. This wasn't just simply a picture where they cropped it out and cropped out the ones around it. It was just showing the actual size of each individual muscle fiber increased through training. So not to beat a dead cat or a dead horse, whichever one you want to do. And why I say cat is because there's a picture of a cat up here on the PowerPoint. Anyway, fiber hyperplasia. So let's go into hyperplasia one more time and we'll try to end this discussion of hyperplasia anyway. So is it possible in humans? Maybe. It does occur, but we don't know exactly how much and how much it plays a role in increasing the size of the muscle. In other animals, absolutely. We actually have studies that show this. One of the studies that was actually done was on cats. And what they would do is they would have this little lever that the cats needed to press to where there was a weight attached to it. And they would hit the lever and a little bit of food would drop. So over time, it was almost a little bit like Pavlov's dogs, kind of. I guess Pavlov's cats in this case, where if they hit the lever, they knew they were going to get food. So each time they hit the lever, they were training their muscles. And they would do muscle biopsies on these cats and see, were they increasing the size or increasing the number? And literally, people were taking these biopsies and they were looking in a microscope and they were counting them. 1, 2, 3, 4, counting all of these muscle fibers. What they found was there was actually an increase in the number of muscle fibers. There was also an increase in size of each individual muscle fiber, but there was also a significant number of muscle fibers that were increased in number as well. So it does happen in other animals, but does it happen in humans a lot? Again, we don't necessarily know to what extent. We know it does happen, but we don't know the whole story yet. So one of the more exciting things that hopefully at some point we'll understand, and some of it could actually maybe be beneficial moving forward. Because if we can create new muscle fibers and do it really well, then if for some reason we have an injury where we lose muscle fibers, we can maybe create new muscle fibers in a lab somehow, or maybe stimulate the body to do hyperplasia versus hypertrophy. Now, there's a little bit of a diagram here, a little bit of a pathway showing kind of what happens. In a nutshell, there's some type of injury, some type of response within the muscles, and that's going to be that small injury that's occurring during weight training or any other type of training. As long as you're forcefully contracting the muscles, this will occur. And this causes satellite cells almost like stem cells of the muscles, causes them to activate, and they're either going to add material and add a nucleus to an existing muscle fiber, or they're going to branch off and create a new muscle fiber. That's essentially what's happening with hyperplasia. It's just creating a new muscle fiber, getting some material from some muscle fiber, and then also getting some genetic information and branching off into a new muscle fiber, or just simply adding its information to that muscle fiber and increasing its size. Now, the neural activation and hypertrophy. In the short term, this is neural. And this is what I was discussing before with the neuromuscular adaptation, that 8 to 10, maybe up to 12 weeks of weight training. There's an increased muscular strength due to those neurological adaptations. There's a very small amount of hypertrophy, whether it's hypertrophy, true hypertrophy, or if it's hyperplasia, doesn't matter. It is very little during this period of time, but there's still an increase in strength. There's a massive increase in strength. And this massive increase in strength is because those signals are more unison, they're more synchronous, and the body knows exactly how to fire those neurons now. Now, after that adaptation has occurred, then most of the increase in performance then after that is going to be hypertrophy related. So there's an increase in the protein synthesis within the muscles. And again, this is the major factor after that neurological adaptation. No muscular talk can be complete without muscle atrophy. Atrophy can occur for a number of different reasons. Immobilization is probably the most common way. If you've ever been in a cast or a brace for a long period of time and you weren't able to move a joint or a limb, then you know what atrophy looks like. It is pretty significant and it happens pretty quickly. I mean, even within 48 hours, a couple of days, I mean, it happens quite a bit. There's a lot of muscle mass that is being lost. Again, the body is only going to maintain what is being used. So if you're not using those muscles, it's going to take it away. It just costs too much energy to keep that muscle mass and keep that tissue alive and keep it running, essentially. So it is just going to be deteriorated. And deteriorated, I mean, the body will still use it. It'll just take it away, use it for whatever it needs to. So there's also strength. Obviously, strength decreases with this. Type 1 muscle fibers are affected a little bit more than type 2 muscle fibers. And if you think about that, that makes a lot of sense, because type 1 muscle fibers that we have in our bodies, those are the ones that we use on a daily basis through almost every single activity. A lot of type 2 muscles, especially the type 2X muscle fibers, they're fairly dormant throughout most of the day. So we don't hardly use them that much anyway. But the type 1 muscle fibers, we use a lot. So those are the ones that are going to be affected more if we are not using them. In this detraining, or maybe a cessation of training, there could be maintenance programs to help avoid some of the losses. So reduction in intensity, duration, frequency, and some of this, a little bit of periodization could be beneficial for this. Again, this detraining is on purpose. You're coming down from a season or maybe even a sport somebody retired from. There are 3 figures on the slides right now if you're listening. We got squat, leg press, and leg extension. And we have essentially a bar graph. And this was actually a female who did 20 weeks of weight training and then took, I believe it was 36 weeks off, and then come back and then trained for 6 more weeks. You had the pre-20 and the post-20. And the pre-20 is the pre-20 weeks of weight training, and the post-20 is what they had after: squat, leg press, and deadlift. And this is all in 1 repetition maximum. So they gained 1 repetition maximum in all 3 of these exercises. When they come back after that long break, there was a decrease in the 1 RM. However, it was still above what the pre-20 was before they even started. So that shows that there is, and I hate using this term, muscle memory. The body still retains some of that neurological adaptation, but not nearly as much. And there's still going to be some decrease in muscle size. So some of the atrophy will occur, But here's the kicker. Just after 6 weeks of training, they were able to not just get back up to where they were, at least in the squat and the leg press, but they were able to get above their 1RM of basically the post 20 1RM, which is amazing when you kind of think about it, at least in the squat, in the leg extension. The leg press, it was maybe a little bit lower, but still, they were still able to get back a lot of, and even maybe additional strength at what they were before they went on a break. So this shows the capabilities of the body to be able to retain some of that strength capabilities even after a long break. Now, if this would have continued for years and years, those strength capabilities probably would have decreased even more so. But just after a few months, maybe even a year, you're still going to be able to retain at least some of those strength capabilities. Just like with fiber hyperplasia and some of the wishy-washy statements I make, I'm going to sound like a politician when I talk about hyperplasia. It may occur, may not occur. Who knows? We need to invest in hyperplasia. Now, sorry. Oh, man, I go on rants sometimes, just stupid. But along with the hyperplasia, another aspect of muscles that we don't 100% know a lot about is fiber type alterations. And that can we actually change and train specifically to change from a type 1 fiber to a type 2 or vice versa? And the answer for this is we don't know. We think it does occur. We have some evidence to show it does, but we're not 100% sure. Now, keep in mind, a lot of this, and along with the hyperplasia, a lot of these studies are based upon muscle biopsies. So you need to take that biopsy in the same exact spot each and every single time, which is going to be difficult to do for a human, especially when your data is separated by weeks or months and you're able to heal that spot where they took the biopsy. So you're not constantly having some type of imaging for that. Now, maybe at some point we get to the technological advancements where we can see literally in the muscles, and we're able to see the muscles doing what they do, growing either each individual muscle fiber or maybe increasing the number. So, but we're not quite there yet. So again, another exciting aspect of research probably coming about in muscle fiber growth. For the aerobic training, high intensity resistance plus aerobic training, the type 2 muscle fibers in that case tend to become a little bit more oxidative, meaning that they start to mimic type 1 fibers. They don't become type 1 fibers, but they start to show some capabilities of taking care of oxygen. They increase the mitochondria. They will increase the oxidative enzymes, but they won't become true type 1 muscle fibers. The type 2X fibers also become a little bit more like type 2A. So all the muscle fibers kind of shift to the aerobic side of things now. Now, if there's more anaerobic training, it goes the opposite way. Type 1 fibers gain a little bit more muscular force production capabilities, but at the same time, those type 1 muscle fibers also lose some of the mitochondria. So there's a trade-off there. Now, a true conversion may occur. There are some sprint studies that show that there could be some possible increase in changing the fiber types from maybe type 1 to type 2 through sprint training, but this is talking about months and possibly even years of specific training. But we do know that it can change if there's a damage that occurs, if there's a neuromuscular damage where the neuron gets cut off from the muscle fibers, so that motor unit is changing. And it's actually the neuron that determines what the fiber is going to be. So the signaling from the brain is actually causing the fibers to act a certain way. I mentioned it earlier on, but let's talk a little bit more about it right now. Delayed onset muscle soreness, or DOMS. So this is the pain that is associated after weight training. It occurs about 24 to 72 hours post-exercise. So there's some stiffness, some severe pain. It could even be some swelling that occurs. The key thing here is, and another myth, it is not lactate. Lactate has absolutely nothing to do with delayed onset muscle soreness or muscle soreness at all. The delayed onset muscle soreness is just the pain of an injury. That's what's happened, is there's an injury that's occurred within the muscle fibers and the body is just reacting to it. Now we have this eccentric versus concentric, such as like downhill type of running. The downhill type of running, that's more eccentrically related. So there's going to be more muscular damage in that case. So that's going to cause more of a reaction. So the more eccentric exercise somebody does, probably the more sore they're going to be. But if you're doing a dynamic workout where you're doing eccentric and concentric combined, you still have the eccentric, and the eccentric is actually where most of the muscular damage is going to occur. So it's still going to happen. And there's really no way around this. And I'll get into that here in a second. Now, what's actually occurring in the muscle damage is the damage is occurring in the Z discs of the sarcomere. So the little area that connects each of the sarcomeres together. It looks really nice and neat on a nice picture, nice drawing, computerization, but this area is made up of like 40 or 50 different proteins. And what's actually occurring is the muscles are, or at least the myosin is pulling the actin towards the M line. But at the same time, you are pulling that apart because you're lengthening the muscle, but the sarcomeres are trying to go the opposite direction. So the weak point in this area is going to be on the Z discs, and those start to rupture a little bit, start to pull apart. So there's some structural damage, and there's a picture up here in the slide, if you're listening, of, you can see a nice fission that has occurred. I mean, this almost looks like a geological feature where there's a big tear essentially in the muscle, and that's actually along the Z disc. And that's what's occurring while you're weight training, is you're basically ripping some of the muscular components apart, those structural components apart. Again, this is an injury that is an injury like a pulled muscle or a torn muscle. These are the microscopic injuries that occur, and these are beneficial. These are absolutely necessary for increasing muscular strength and muscular performance. So once that's occurred, what's happening is there's an inflammatory reaction, and that's where you maybe start to get some edema and some swelling build up. But there's an increase in white blood cell production, and going to the muscles, we have some neutrophils that are going to be attracted to the cells, and they're going to release what's known as cytokines and causing some O2 radicals to be produced. And this is what's known as oxidative stress. This oxidative stress is also going to cause a stimulation of the nerve endings. And that's what's happening with the soreness. That's what's causing the soreness. It's not lactate, but it's the reaction of the injury is why the muscles are sore. You're just stimulating the nerve endings because of this oxidative stress that's occurring. And this oxidative stress is important to react to get out some of the debris, get out some of the junk that's around there. And then in the end, we get more protein into the cells, and there's a fiber regeneration. We have testosterone, growth hormone that's released, and that causes a change in the structure and causes an increase in protein synthesis and causes the fiber to be built up bigger and stronger than what it once was. So are there ways of reducing DOMS? Well, there's really no way of eliminating it. The only way you eliminate it is don't even do it at all. But then that's not very beneficial. You don't even weight training. But you can reduce it kind of. You can start slow at a low intensity. So this is maybe a reduced eccentric phase contraction during the workout. But it could be drawn out a little bit longer because this is going to occur regardless of what anybody does. It's just, is the soreness going to last a few days or is it going to last a week or 2 weeks? I mean, it shouldn't last 2 weeks, but maybe a week and a half. There could be some additional exercises somebody's doing if they start really slow over a 2-week period and then start to ramp it up. Or do you just say, you know what, I'm going to be hurting this week. I'm going to go into it, start fast, high intensity. I mean, not so much where you're going to actually injure yourself or a client. So this is something you need to think about if you're training somebody. Do you start them off slow or do you start them off fast? Regardless, they should be aware that this is going to happen. There is going to be some sort of soreness that's going to occur within the next couple of days, and they need to be aware It may be a little bit stressful and painful to walk up and down the stairs or even just take a poop. It's it's going to be somewhat painful. There's going to be some muscle soreness, but that's part of it. It should be looked at as a positive. It's a good thing. But if you start fast, high intensity, there's going to be a lot of pain at first. But it should be less as somebody continues then over the next week or so. Now, there's a subsequent overload effect here too. And I don't want to get into too many of the principles, but there could be some neurological aspects, some structural components there. Could even maybe be some hormonal responses. But as somebody continues to weight train, there's not nearly as much soreness that occurs. In fact, some of the soreness almost never occurs again because of this progressive or subsequent overload, that occurs. So that initial soreness, that's going to be the worst one. As long as somebody can get past that, they should be good to go. The main thing here is just simply working through it. The performance is going to decrease, and that's part of that general adaptation syndrome, but it's going to decrease, but there's going to be a resistance phase, and the body's going to respond to it and increase the performance as long as somebody sticks with it. So everything's going to be honky-dory in the end anyway. And that was chapter number 10. I'll see you here in a bit for the wrap-up. Why don't we have a little fireside chat to go along with this chapter? All right, so I kind of went over a little bit of a rant in that first slide, going over the benefits of weight training for men, women, athletes, non-athletes, young, old people. Doesn't matter. A couple things I wanted to go into. The young. Again, there are, and I touched on this, but I kind of want to talk about it a little bit more. There's still a lot of people that believe that young people, and I'm talking young, like even people who have started puberty, 12, 13, 14, even up to 18 years of age, but prepubescent children should not ever be in a weight room, should never do any type of weight training. It's absolute garbage. They can do it. The thing is, they need proper guidance for it. That's where the problems occurs, where they don't have proper guidance and they're just doing stuff and they have no idea what they're doing. That may induce some injuries. It's going to maybe cause some problems there, but if they're doing everything correctly, then there shouldn't be any problem. And are they going to gain as much muscle mass as somebody who's gone through puberty, whether they're male or female? No, they're not, but it's still going to be beneficial. One concept I want to, inject into this is children are going to grow better when they're working out, when they're active. The least amount of growth in children occurs from the months in general, occurs from September to May. Gee, I wonder what they're doing during that period of time. They're sitting in a classroom for 7 or 8 hours a day. They're getting very little exercise. The food is, it is what it is. They might get 10 or 15 minutes of recess, but no, we got to have more science and math. And that's I'm not saying science and math isn't important, but it'd be more beneficial if they got a little bit more physical activity throughout the day. The months in which they grow more, I'm talking children now, is the summer months, essentially May, June to July, August. When they're not in school, they're actually outside playing with their friends or doing stuff outside. That's when they grow more. So, yeah. And anyway, young people still going to benefit from it. Again, they need the proper guidance and supervision with it. Also, older individuals, they are going to benefit from it probably more than anybody, to be honest with you. In fact, there's lots of studies from it. We actually had a program when I was in grad school at Kent State. It was a senior exercise science, exercise program, where we had senior citizens from the community come in, and we had a class that was designed for this, to where we had students that were actually working with the community members, the older people, and had them doing simple weight training exercises. Sometimes we would have them go in the weight room and actually do Some of the exercises on the pieces of equipment, there was no free weights. It was all machines. Sometimes we have them do TheraBand exercises, even soup can type of stuff, and have them do some get up and go tests. And there's a lot of different tests you could have had them do, but it was all beneficial to them. Even the people who were doing some type of weight training, they were benefiting greatly from it. And why that is because they were building their bone health, or at least maintaining their bone health, but also gaining a little bit of strength or maintaining their strength. And they could do those daily activities. They could be more autonomous. They wouldn't have to have somebody help them. They would delay the time that they would have to maybe go into a home as they got older and older and older, getting to really old age, 90s, and even into maybe be a centurion. But it was beneficial for them. It will decrease the risk for fractures. It will not increase the risk for fractures. And that was one of the myths way back in the day, that they were going to break their bones and stuff. And kind of going back to the younger people, oh, you're going to stunt your growth if you weight train. It's like, oh my goodness, that's absolute nonsense. Athletes and non-athletes, it should be, and we're talking about like normal age people at normal age. I don't know what normal age is, but basically teenager up until, 40s, 50s, something like that. Athletes or non-athletes, obviously the athletes are going to benefit from it. Non-athletes, they're going to benefit from it from the health aspect, but also the daily activities aspect. Men, they're going to gain strength. They're going to gain endurance, power, whatever it may be, beneficial. And females was the other one that I discussed. Again, I still hear it. Even in 2020, I know how crazy 2020 has been, but I still hear people talk about women weight training, and females themselves don't want to weight train because they don't want to get too bulky. And I hear coaches, collegiate coaches, high school coaches in particular, say, no, I don't want my female athletes weight training because they're going to get too big. Oh man, I cannot believe we still have this myth that females who are not taking steroids, who are not taking any type of performance enhancing substances, are going to gain this massive amount of muscle. It's not going to happen. They're going to gain muscle. Absolutely. It's not going to be anywhere near the amount that a man will. Just pure and simple. They just don't have the testosterone in their bodies. So it's still beneficial for them, though. They're still going to increase the performance. Man, pound for pound. And I mentioned this, pound for pound, females are going to gain just as much strength, if not more, than men. In fact, I believe some of the stats that I've seen, females actually gain pound for pound a little bit more muscle gain than men do. But now overall brute strength and overall muscle mass, weight, men will gain a little bit more. Another thing too, kind of with that, with athletes, and specific athletes, endurance athletes, I still hear this too, that long distance runners should not weight train. Again, these are from professionals who do this for a living. And they believe this. They still have this myth. I'm not saying that a long distance runner should be training like a power lifter, but incorporating some resistance training has been proven. There's evidence to show that it's beneficial for that athlete. Hopefully we get past some of this. I think we have for the most part, but there's still some of this garbage that's still kind of floating around out there that, I don't know, for whatever reason, we still have myths and misconceptions about weight training. And there's other ones too. And there's a lot of other things that I would love to get into, teach a class on it at some point. A lot of the myths and misconceptions, a lot of it's going to be around supplements. But also if you look at any type of, if you're up late at night, you'll see a lot of infomercials. They are just absolutely insane. Some of them are beneficial, some of the pieces of equipment that are being sold, but other ones are just an absolute waste of money. But people are making money off of it. So, but I am here to try to at least relay some information, try to save you some time and money for it. But anyway, that is a little bit of a rant there for chapter number 10. What are the things that we go into? Hyperplasia, kind of, again, beat that dead horse or beat that dead cat. Because there was a picture of a cat there. I'm not saying you should beat a cat or beat a dead cat. I have a couple cats myself. I love them to death. So, don't. I'm not a cat hater. So I actually enjoy cats more than what I thought I would once we got them. But anyway, where was I going with this? Squirrel. All right, muscle hypertrophy, muscle atrophy. Went into some concepts of that, and then where the damage occurs while you're weight training, and that damage, that little microscopic damage within the Z discs. And what I wanted to kind of show, if you're watching the video, is that I'm interlocking my fingers now, and this is a good representation of the sarcomere, where my knuckles would end up being the Z discs. What's happening is you are trying to, or the muscles are contracting this way, where the myosin is pulling the actin towards the M line, but you are pulling it apart during the eccentric phase. So the muscles are moving this way towards the M line, or contracting that way, but you are essentially pulling them apart. That puts stress, and the weak point is on the Z discs, and that's where they start to rupture. That's what causes the damage. And most of that damage is going to be occurring during the eccentric phase because of those two opposing forces that's occurring within the muscle fibers. So that's what happens there. And lactate has absolutely nothing to do with the soreness that occurs. It has everything to do with the response of that damage, that rupturing that's occurring, that inflammatory response, the oxidative stress that's occurring, that's going to stimulate the pain, basically nociceptors within the muscles or within the body, at least underneath the skin. There's going to be some edema, and that's going to be causing some pain receptors to be stimulated, and that's what causes the soreness. So lactate is cleared out by then, has, again, nothing to do with it. But continuing to do that type of training with those specific muscles, there's a lot of different reasons why you don't get that same response as the initial pain, subsequent workouts, but it is actually a principle. It's a subsequent bout and subsequent overload that is occurring. And there's a couple of different theories on why we don't have that soreness as we continue to do it. Some of it's structural, some of it is neurological related, some of it is just possibly hormonal related, and just response of some of the chemicals that are being released, but probably a combination of everything. But I'm not going to go into detail about that. That's kind of beyond this course, but we shouldn't have any type of additional soreness past the additional DOMs. There might be a little bit here and there, depending upon what the workout is and how long. Maybe there was a break in between workouts of like a week or week and a half, something like that. So I think my cats are running around. Dogs are probably chasing the cats. So I'm just going to go ahead and end this chapter. I thank you for watching. Thank you for listening. If you have any questions, comments, anything like that about chapter number 10, Adaptations 2, resistance training, please feel free. Put them down below if you want to. But if not, thank you for watching. Thank you for listening. Y'all take care.